Hello viewers, in today's session we are going to discuss a very important and conceptual problem from limits involving the fractional part function and greatest integer function. So here we are given this problem in which limit x tends to 2 positive. This positive sign shows that we have to find the right hand limit of this function involving the fractional part function and greatest integer function, right? So we have limit x tends to 2 positive, fractional part of minus x minus 2 divided by greatest integer of minus x minus 2 is equal to minus lambda over mu, where lambda and mu belongs to the set of real numbers, and we have to find the value of lambda plus mu, right? So here what we will do, we'll find out the value of this limit, and then we'll equate that value to this number, that is minus lambda over mu, and by method of comparison we'll see the value of lambda and mu, and then we can find out the sum, that is lambda plus mu, right? So here we'll make use of the definition of fractional part function and the greatest integer function, and one important property of greatest integer function to solve this problem, right? So let us start. So here we have to find the right hand limit, and here x is approaching towards 2 from the right of x is equal to 2. So here we have x is equal to 2, and we are approaching towards x is equal to 2 from the right of x is equal to 2. So we are in the neighborhood of x is equal to 2, and this point is 2 plus h, right? So what we will do, we'll take x is equal to 2 plus h, and when x tends to 2, then obviously h tends to 0. And remember, this quantity h is a positive quantity and it lies between 0 and 1, and h is infinitesimally very small, right? So let us convert this limit in terms of h. So we have right hand limit is equal to limit. Now we can replace this x tends to 2 positive with h tends to 0, and here we have fractional part of minus x minus 2. So x can be replaced by 2 plus h, and then we have minus 2, and here in the denominator we have minus 2 plus h minus 2, right? So now we can simplify it. So we have limit h tends to 0, and now we have here minus 2 minus h, and here we have minus 2, and in the denominator we have greatest integer of minus 2 minus h minus 2, right? So now we can write limit h tends to 0, and here we have fractional part of minus 2 is minus 4 minus h, and here we have greatest integer of minus 4 minus h, right? So now we have to evaluate this limit, and remember, whenever we come across with the special functions like fractional part function and the greatest integer function, we cannot directly substitute h is equal to 0 over here, right? So what we will do, or our next step, is to utilize the definition of fractional part function, right? So the fractional part of, say, p is defined as p minus greatest integer of p, right? So now we can write this limit as limit h tends to 0, and here a fractional part of minus 4 minus h can be written with the help of this result, that is minus 4 minus h, and then we have minus greatest integer of p. So p is our minus 4 minus h. So here we have greatest integer of minus 4 minus h, and in the denominator we have greatest integer of minus 4 minus h, right? So now here what we will do, will make use of one important property of greatest integer function, right? And the property goes like this: the greatest integer of x plus m is given by greatest integer of x plus m, right? Where this x belongs to the set of real numbers and m is our integer, right? So greatest integer of x plus m can be written as greatest integer of x plus m. So we can isolate this m, where x belongs to the set of real numbers and m belongs to the set of integers. So here z denotes the set of integers. So now we can apply this property to a greatest integer of minus 4 minus h. So we can now write this expression as minus h plus minus 4, right? So now if we compare this one with this one, then our x is h, that is minus h, and m is minus 4, and obviously minus 4 is an integer, and minus h belongs to the set of real numbers. So we can now write it as greatest integer of minus h, and then we can write here minus 4. So this is now greatest integer of minus h minus 4. So replacing this term and this term with this one, we can now write limit h tends to 0, and here we have minus 4 minus h, and then we have here negative sign, and then we have greatest integer of minus h minus 4, and in the denominator we have greatest integer of minus h, and then we have minus 4. So now we have to calculate the value of greatest integer of minus h, right? Because greatest integer of minus h, it appears here and here, right? So the greatest integer of minus h is equal to minus 1. Why? Because see, h lies between 0 and 1. So if we multiply this inequality throughout by minus 1, we have 0. The direction of the inequality get reversed. So here we have minus h, here we have minus 1, right? So this inequality can also be written as minus 1 minus h and 0. So this inequality indicates that minus h, it lies between minus 1 and 0. So the greatest integer of minus h should be equal to minus 1 by the definition of greatest integer function, right? So we can now replace greatest integer of minus h by minus 1. So our limit is equal to limit h tends to 0. Here we have minus 4 minus h, then we have here minus 1, and here we have minus 4, and here we have minus 1 and minus 4. So now we can write limit h tends to 0. We have minus 4 minus h, and here we have minus 5, and this becomes positive 5, right? Minus 1 minus 4 is minus 5, and then we have minus times minus 5, that is plus 5, and here we have minus 5, right? So now we have a simple expression here, and we can now take h is equal to 0. So we have minus 4 minus 0 plus 5 divided by minus 5. So this is 5 minus 4 is 1, and here we have minus 5, right? So our right hand limit, that is this limit, is now equal to a negative of 1 over 5. And in the problem we are given that this limit is equal to minus lambda over mu, right? So now if we compare both these sides, we get lambda is equal to 1 and mu is equal to 5, right? So now we have to find the value of lambda plus mu. So the value of lambda plus mu is equal to 1 plus 5, that is equal to 6, right? And obviously lambda and mu belongs to the set of real numbers. So this is how, by making use of the concept of fractional part function and greatest integer function, we can solve these type of problems.